First speaker is Kota Miura, BioImage analysis legend. So, all yours.
So, what kind of legend depends. Thank you. So this is the news. It's in a poster that is hanging. It's new, but so Globius, Global Bioimage Analysis Society, officially launched as an international society on October 24th. So it's like, thank you. So officially means that registered, right? And then it's stamped now. So this was based on the support of CZI. And of course, there has been a long-standing Novius effort. And some of the organizers, including Perrine right there, raise hand, raise hand, yeah. And Fabrice, yeah, and Sebastian, yeah, and then Clara, yeah. So we've been working on Novius, and now the next generation, younger, fresh analysts are organizing this. And then, so please, when you see these activities, make attention. I want to have your attention, and then we have actually a small meeting next week in Sweden. But we're going to have a much larger one. The place is not determined yet, but next year. So please make your attention. So let's go on. So the talk is not really about Globius, but it was about activity we did with Quarep Limi, working group 12. So the title is like this, but in essence, it's about how to avoid wrong image analysis in life sciences. So what is wrong image analysis? Here's an example. So this is what you do, probably even teaching. Like you have this nucleus image, a lot of nuclei, and then you threshold, and now you want to, let's say, do an automatic measurement of DNA contents or something. And then what you do in case of Fiji or image J is that you do particle analysis and then you segment it and then use some intensity measurement. And then each individual nucleus is measured with the intensity area and so on like this. Okay. I mean, it's probably you do this, many of you like this. But this is wrong. Yeah? This is wrong. Because the segmented area is affected by the intensity. How could we then measure the intensity properly, right? So I know some of you feel really frustrated because you've done it and wrote paper or something. But, so this is so there has been a lot of controversy. So we even did a detailed study of this effect. So we made artificial circles with a different intensity. So this is 67% higher intensity with identical area. If you do automatic thresholding, you get 44% higher. So that there's a, you didn't really measure properly if you do automatic segmentation. So if you want to know how to do it properly, I can tell you, but come to the poster. So yeah, that's bad image analysis, wrong image analysis. But if you see papers, sometimes you see this kind of description that ends like images were analyzed using image J. Yeah, so this is bad, yeah, because we cannot evaluate even if this analysis was okay or not. Yeah, so instead, write fully described methods in papers so others can reproduce the methods. Be ready for reviewing. In this case, reproducibility is, it's part of the FAIR principle, but the main aim of the reproducibility in this sense is that it's an indicator of full description. It's fully described, then we can evaluate. Makes good science, right? So I think there's many ways to control image analysis. So one way is to make some kind of rules. So that the rules that you should do this, you shouldn't do this. But science is not like that. You can do anything but report, including mistakes. And then we want to follow that also with image analysis. Then there are cases of more detailed descriptions. Yeah? So it's much longer than ImageJ was used, so that you see a lot of details. But I mean, if you see in detail, there are a lot of things that is not really clear what was done. For example, deconvolution. There is no indication about which algorithm was used. So there's some co-localization analysis, but we don't know which plugin or which software was used, or was it really custom made? But there's a co-localization master there, Fabrice. I think he would complain a lot with this sentence. Huh? And then chymographs. So how did it, so where's the ROI? Region of interest, we don't know. So this kind of description looks detailed, but it's not enough. So how can you do that? Record everything. So this is a case of ImageJ, that if you do these kind of processes using graphic user interface, you can have record of what you did, and then you can create a script. This is the image macro. What you can do is just submit this record. This is the most detailed description of what you did. Like there's an indication of which algorithm was used for thresholding. There's so how many pixels was given as a parameter for area opening. So we can reproduce, which means that we can evaluate. How do we submit? We need 3 components. So one is workflow codes, what I have just shown, just a record of what you did. And then sample image data with ROIs, especially if you use manual ROIs, you can save it and then submit together with the code. Then this is reproducible. And then we have to know how to run it, which software is used, which version was used. If the plugin was used, you have to have the version of the plugin as well, and so on. So this is the basic element of full descriptions. So I'm saying that you should submit code instead of text, because computer code, you often think that this is for automation of workflows, but there's another very important aspect of codes, which is another way of describing your methods. So if this is a chemistry, you use chemical formulas. If it is physics, use mathematics to make a precise description of whatever is done. In case of biology, somehow the tool is there, but people don't use it, which is code. You can record it. Right? Okay, so for the data, we need image data to reproduce. And then there's many repositories. So there are general repositories like Zenodo or Figshare, Dryad, Mendeley data. But of course, I mean, now we have more focused repositories of image data for like such as BioImage archive or SSPD repository, which is the Japanese version of this image data repository, which Onami-san is organizing. Onami-san was there, but okay, yeah. So ask him. He's a specialist. Then there are, so this is a kind of control metadata, but there's even more added value image data, which allows you to reuse data in full, with a full information annotated with all these images, like IDR, which is from JSON, right? And so I don't know about these things, but this, again, SSPD database is edited by image data, which is organized by Onami. Okay? Next. So now, I explained about this, and then we need some kind of a very concise summary of what you need for publishing reproducible image analysis. And this is a paper that we published together with 54 imaging scientists in Nature Methods. And then it's a short paper with these tables of lists of required components of submission, for submission. So, I mean, I wanted to explain about this, but of course we don't have time like this thinking. So I had chance last week to review a single issue of Journal of Cell Science for the reproducibility based on this checklist. I just read all these papers, and amazingly, all papers use image analysis. And then I carefully checked if they have those components, and the majority of them only had description. And one of them even didn't describe anything but only image data. Yeah? But in any case, overall, everything was failed, had failed with this reproducibility. So we have a lot to do. I mean, from now on. But in any case, I want to tell you that all these methods, it's kind of interesting to see what's the actual image analysis that people are doing. It's manual annotation of ROI and intensity profile and co-localization analysis. Those are the three major analysis techniques that people use widely. So it's not actually all this AI-based segmentation or more sophisticated workflow with a lot of processing. It's really the basic thing. But even with those basic things, it's not reproducible. So my conclusion is we have a lot to do. So I'd like to acknowledge, especially the two leaders, Helena and Christopher. They were leading this WG12 and Lemmy for publishing this paper in Nature Methods. And recently, Mike Nelson has been very passionately working on the website that supports this checklist, and Roland for organizing all this Correct Lemmy. And then so I was always wondering what Correct Lemmy stands for, and then I had a chance to check the actual quality assessment and reproducibility for instruments and images in light microscopy. So yeah. And then I also like to thank the co-author of this paper that I wrote in EMBO Journal in 2021, which became the base of this list. And then Nuno for the making some initial kick to that eye to think about reproducibility. And then Bernd Pulfea, so he's the EMBO Journal editor general. He actually had a lot of materials that to think about this. And for the reviewing of the this kind of idea about reproducibility, Perrine, Giovanni, John, Sebastian, Toshi, and Martin Schob. So they really passionately, so it took years to write this paper, and then another 3 years to write this methods paper. But anyways, thank you very much for your attention. And then if you have